Bienvenidos, Ushamdid, and welcome to this Enterprise Networking Security and Automation CCNA version 7 techtorial, which is going to cover Packet Tracer Activity 10.8.1, where we are going to take an in-depth look at CDP, the Cisco Discovery Protocol, LLDP, the Link Layer Discovery Protocol, and Ntp, the Network Time Protocol. Now, one of the first things we need to talk about is the fact that CDP is Cisco proprietary. And so, in other words, Cisco saw a need in the marketplace and saw a need technically for something that didn't exist, and so they created CDP. Now, here's the activity we're going to be working through, but we're going to be going into much more depth than this activity. I've got the Cisco Modeling Labs, or CML, formerly known as Viral, and we're going to take a look at some examples of CDP and LLDP there. And I have physical Cisco 3945 and I believe a couple 2911 routers. And we're going to see what CDP looks like on physical routers as well as LDP. And whether or not CDP is on by default or is LLDP on by default and how exactly does that work. So right out of the gate, we're going to take a look at this activity here. And you can see we're being asked to configure CDP, LLDP, and then Ntp. And so what I'm going to do right out of the gate, because I know Packet Tracer and I know Ntp very, very well, so we're going to actually do the Ntp configuration step first. That way it's going to have time to sync up and do what it needs to do. And so we're going to configure the headquarter router to use Ntp, and it's going to use this device right here, 192.168.1.254 as the Ntp server. And in fact, the answer to the question, or to the configuration work that we need to do, is right there in that statement. So we're here in user exec with the greater than sign. We're going to transition to privilege exec mode using the enable command, and then in a global config with configure terminal or just conf t. Now, I said that the answer is right there. So what if I was to tell you that all you needed to type to configure the HQ router to use the server 192.168.1.254 as the Ntp server would be that command right there. And that is actually all that's required. Now, there is no key specified here, and in fact, there are a couple other options that we might be interested in. So if I was to come over here to our Cisco Modeling Labs, and here I am on iOS v0. So this is just an iOS router, a virtual iOS router, and I believe we're running 15.8 code. And let's take a look at, did it go by there? So you can see we're running 15.8 code here. And so if I was to go into global config here and say Ntp server 192.168.1.254 and do a question mark, you can see we have a few more options here. The one I want to call to your attention is this one here, which is the prefer option. Again, we don't see this in Packet Tracer, but this is a good option to know and to understand, because maybe you have more than two NTPs or more than one Ntp source server identified, and you want to prefer one over the other. And so I would say prefer, and then let's say we had another which was 253. And so what those two configuration commands are doing is they're defining two sources for R0, router 0, to get its Ntp time information from 192.168.1.254 and 253, but I'm preferring 254. Maybe it's a lower stratum level. Maybe I have redundant links to get there, or redundant paths to get there, or that is a more robust platform, and I want to prefer that router, right? But 253 is there in the event that 254 goes away. So again, quick sidebar, but a good option to know, because that option's not here in Packet Tracer, but that's a question learners commonly ask. Well, if I've got more than one Ntp server, how do I choose, or how do I know which one I'm going to use? Well, that is how you can hard code that option. So I'm going to go ahead and hit enter. You can see And it's very small down here in the lower right-hand corner. Our completion percentage has gone to 7%. And the reason I'm doing the NTP server command first is when I say show NTP status, you can see the clock is unsynchronized. The stratum is at the maximum stratum value of 16. And so it could take a while for this to sync up. And instead of doing this at the very end and then having to wait around for it, we're going to do it right now. And then now we're going to move on to the Cdp and Lldp configuration. So we've got some background work here, or background scenario information here, but let's get into our configuration. We can click the fast forward time button if we need to. We shouldn't need to here. So the first thing we're going to be asked to do is configure Lldp as followed. Now, Lldp is an IEEE standardized protocol that is going to accomplish much the same thing that Cdp is going to do for us. Again, remember, Cisco saw that there was no protocol out there. They saw a need in the marketplace. Technically, they created Cdp, layer 2 protocol, Cisco proprietary. And then, of course, the IEEE, like they commonly do, MPLS being a great example, spanning tree, in some instances being another good example, went ahead and said, hey, that's pretty cool. Let's create a standardized version that'll run on all vendor platforms. And so we have IEEE 802.1, capital A, capital B. So 802.1AB covers Lldp. Now, it is vendor neutral, right? And so that's key to remember. So let's walk through these steps here and let's get our configuration knocked out. So it says disable Cdp on the HQ router. Well, we're already on the HQ router. How do I check to see if Cdp is actually currently enabled? Well, I would say show Cdp. And you can see right there that we have our information that Cdp is, in fact, currently configured and running. And by default, Cdp is on. If I come back over here to our Cisco Modeling Labs and say show Cdp, you can see Cdp is on by default. What about Lldp? Lldp is not enabled by default. What about on physical Cisco routers? And we'll come here to router number, we'll come over here to router 10. So here I am on router 10 and it's asking for username, password, and those were not supposed to be asking for username, passwords. So here we are on router 14 and let's just say show Cdp and you can see it's running by default. And what about show Lldp? And it's not. And the version here of iOS is 15.6, so a recent version of iOS. So our takeaway is that Cdp, Cisco's got that on by default. Lldp, Cisco does not have that on by default. Now, we'll talk about the security ramifications of Cdp as we move through the activity. So the first thing it's asking us to do, we'll get into global config, it says disable Cdp on the HQ router. Well, that would require us to know what the command is that turns on Cdp on the router. Well, it would be Cdp and run, right? And you can see that would be the command from global config. And that would turn Cdp on router wide on all interfaces on the router that are up and that are, not shut down. That is going to turn Cdp is going to run auto-magically. So I would say no Cdp run. And you can see we got 5 percentage points and it bumped us up to 12. So Cdp run is on by default. No Cdp run is going to turn Cdp off. So how might I check that to see what those defaults might be? Well, what if I say show run all and then pipe it to include Cdp? What do we see here? We see Cdp run. Now, remember, this all option is going to show me a lot of the default values. Take a look. And again, I'm filtering here, including the string Cdp. So I'm filtering down just to see what Cdp has got configured, but there's my Cdp timer, right? How often is Cdp generating layer 2 messages that are being multicast out onto a link? They do not get forwarded. And I'll talk about that as well in a little bit here too. And then the hold time is 180 seconds. So the timer values are similar to a routing protocol that's called BGP, the Border Gateway Routing Protocol. So, and just like we have OSPF, has a hold time and then a dead time. And EIGRP, same thing, 5 seconds and 15 seconds respectively. So we've got these hold timer values and hold time value, and these are set by default, and we can see that here. What if I was to say show run all and include LLDP? And what do we see? Well, we don't see much of anything, right? So it's off by default, and that command doesn't show up in here. But this is turned on. CDP is turned on by default, and there's that CDP run command, meaning that it's going to be running on any of the interfaces that are up. If I was to say show CDP interface, take a look at that. I've got a lot of sub interfaces on here. You can see gig 010, gig 011.4, or 114, 214, 314. Again, a scenario, a scheme that I've got set up in my lab. And take a look at that. It's showing me that it's up. It's sending CDP packets every 60 seconds. And there are all the values. And take a look at that. I haven't enabled it on interfaces individually. It's just globally enabled. So these interfaces, which are up, are sending and receiving. And I guess it's important to say that, right? With CDP, there is no separation between sending and receiving. Both activities, when an interface is using CDP, are active. So CDP being enabled on all interfaces are sending and receiving information. If I said show CDP neighbor here, take a look at that. Again, I see the device to which I'm directly connected, because these CDP messages don't go to this switch right here, this 3550, and then the switch says, oh, well, let me forward these on as if it's an OSPF LSA, an update of some kind, right? A routing update that might be taking place. That's not what is happening here, right? So those aren't being regenerated and then sent back out through the environment or forwarded along. So I do see my neighbors. And again, CDP on by default, LLDP not on. So we disabled CDP on the HQ router. Let's enable LLDP globally on the HQ router. Well, how do we do that? Remember I said do show LLDP, and you can see it's not enabled. Well, one of the nice things about LLDP, at least in the Cisco implementation, is that the command set is very similar to CDP. So just as I would say no CDP run or CDP run to turn CDP on, the Cisco Discovery Protocol, what I could say is LLDP run. And let's see what that does. Sure, we get 5 percentage points out of it. And now let's say do show LLDP. And now we're getting information that LLDP has been activated. Now let me say show LLDP, and let's do a question mark here. And you can see I can say neighbors, and that's all we see. But let's take a look over here on the physical Cisco router, and let's say show LLDP, and you can see LLDP is not enabled. Well, we know we just say LLDP run. And so now let me go ahead and say show LLDP, and you can see here we get some information. Again, the same information that we were seeing when we said show CDP, right? So what if I was to say show LLDP and do a question mark, and you can see we have other options here. What if I was to say interface? Now, I could hit enter here, and it's going to show me what's going on. And this is important, right? That show CDP interface and the show LLDP interface is important here, because take a look at what's happening. It shows me that the transmit and the receive are enabled, right? So by saying LLDP run and turning LLDP on, I've enabled transmitting and receiving on the interfaces. And you can see if I was to scroll down, it's going to be the same for all of these guys here. Now, the transmit state is idle, and the receive state is waiting for frame. Because again, we don't have any other routers here that have been configured to send or receive LLDP, because it is off by default on all the routers in the environment. So let's take a look at, I believe, router. And let's go ahead and real quickly here, and let's just say configure, replace, flash, sub.base.cfg. And again, what I'm doing here is I'm just overriding the router config with a configuration that I have for this router. And we'll see, and again, we want to take a look at this. If you see here, I'm running 15.1 on this router. The other router's 15.6. So if I say show LLDP, you can see that it doesn't even know what that command is. So LLDP with 15.1 code, it's not even there, right? So the command option's not even there. What if I go to try to turn it on? Maybe you're thinking, hey, what if you said LLDP run? It's not there. So in Cisco iOS, this is a more recent convention. And again, we see the transmit in the enabled state. So we've turned on LLDP. Let me say show LLDP. And again, there's that information. I see the timer value. I see the hold timer. And we can manipulate those values. Now, chances are you're not going to do that, but know that you could manipulate those values if you wanted to. CDP, you would just say from global config. I could say, sorry, and actually let's do this over here because it might not be available in Packet Tracer. I could say CDP timer, and I can change the value. I can drop it all the way down to 5 seconds. And then I could change the hold time. I say CDP hold time, and you can see here I could drop it to 10 seconds, but let's make it, we'll just leave it, we'll change it, or I should say we'll change it to 60 seconds, right? Now, I've enabled CDP here, right? And if I say do show CDP, let's make sure that it's up and running. And you can see my values for the timers have now changed. My timer value and the hold time. In fact, let's take a look at a packet capture. We'll use Wireshark here. And let me kick off a capture. And what we should be seeing is every 5 seconds, I've got some CDP activity coming in. And you can see right here, it's R14, R9, R14. So R14 is where we made the change. And then we've got some other stuff going on there, but let's stop our capture here and let's take a look at this CDP packet, right? So remember, CDP is a layer 2, a data link layer protocol. And you can see we're running version 2. Our time to live is 60 seconds, right? That's that hold time value that we just sent. And then take a look at the different information that we get here. We get the device ID. We get software version information. Take a look at that. Right, some very robust information. We get the platform information, the port ID, different capabilities. And if I was to drop down the logical link layer here, you can see we've got some other information that's in here in terms of the DSAP, the SSAP. And if I was to come up here to the layer 2 information where we've got our MAC addresses, there is the multicast address that's being used on the link for CDP, and you can see VTP, DTP, but we know that this is a CDP packet because it's Cisco Discovery Protocol right there. So again, Wireshark, free to download, highly recommended. Let's jump back over here to the packet tracer activity. So we've enabled LLDP globally, meaning it is running, and it is running on all of the interfaces on this router. So now on the HQ router, configure the links to the switches to only receive LLDP messages. In other words, we want to turn the transmit capability off. We just want to receive. Now, this kind of brings us to our security, or one of the security discussions we're going to have, and that is, well, why would you disable on the HQ router? Why would I only want to receive, and I guess we'll change the color to a yellow-green here. Why would I want to receive, right? But turn the transmit off. And if you think about the passive interface with OSPF, the logic runs along the same spectrum. I don't want to be transmitting LLDP packets out these links, multicasting packets out these links. Again, on the HQ, configure the links to the switches to only receive LLDP message. So I want to get the information. I don't want to send any information, right? And that could be for security reasons. It could be that we don't want these switches to get that information. But think of it as like you can selectively passive interfaces, right? And we can do the same thing with CDP. But again, we're first doing it here with LLDP. So let's go ahead and clear our screen here. and we're on the HQ router. And so those two interfaces, do show IP interface brief, are going to be gig 000 and gig 001 on the HQ router. So let's get into int gig 000. And then the question becomes, well, how do I configure the links to only receive LLDP messages? Well, let's say LLDP question mark, and you can see right here, I only want to receive. And so if I only want to receive, I would say no LLDP transmit. You can see I did the receive. I think it bumped us a few points, and that just pushed us 4 points. We'll take a closer look here on gig 001, and you can see it's asking us to say LLDP receive, and that gets us 4 percentage points, and then no LLDP transmit. So let's go out to a real Cisco router and see if that is actually what's going to be required here, right? So here I am on this router, router 14. Let me say do show IP interface brief, and you can see we've got interfaced gigabit Ethernet 00 dot, and actually before we do that, let's say LLDP run. So do show LLDP, and you can see there are the configuration options that we have right now. So every 30 seconds is going to be an LLDP packet will be sent, and then 120 seconds is sort of our keep alive time. Now, let's drop out here to the packet capture, and let's kick that packet capture back on. We'll say continue without saving, and let's see, do we get within 30 seconds, do we see any LLDP packets? In fact, what we could do, and let's come back over here, and if I was to say question mark, you can see LLDP timer, I can actually set the rate at which packets are sent. So I'm going to drop it to 5 seconds to hopefully, and there we go, right? I was just trying to more quickly sort of generate these LLDP packets. And let's go ahead and kill that. And you can see here the system name is R14, Link Layer Discovery Protocol. So we get chassis information. We get all kinds of information. So by enabling LLDP, and if we were to take a look, you can see a different multicast address here, this LLDP multicast. And I think I said earlier, it's referred to as a MAC. It looks like a MAC, right? But that is the hex address that is being multicasted to for LLDP. So now let me come back over here, and let's say that I only want to transmit, I don't want to receive on that interface gigabit Ethernet 00.10. So how would I do that? Well, let me go ahead and say LLDP, and do a question mark, and you can see here I've got receive and transmit. So I'm going to say no LLDP receive, because the question is, do I have to explicitly say that I want to transmit, or can I simply come in here and say no LLDP receive, and it will continue to transmit? Remember, do show LLDP interface, and this is the interface we're on here, and take a look. Transmit is enabled, receive is disabled, my transmit state is idle, my receive state is in a init, because again, the receive has been disabled, but we haven't, it would say waiting for frame if it was enabled, but it's going to sit here in a init because I've disabled it. But the question is, can I disable the reception of LLDP messages, but continue to send them? And it's easy to check with a packet capture, right? Continue without saving, and is router 14 still sending, still transmitting messages? And take a look. It is, right? So the takeaway here, and the reason I wanted to show you that, is Packet Tracer is not giving me points, right? It's going to keep points away from me if I don't say LLDP receive, right? I have to put both of the commands in the configuration here, is what I'm getting at, right? And so when I say LLDP receive, no LLDP transmit, remember that if I wanted to receive or I wanted to transmit, but I didn't want to do, if I want to do one or the other, I only have to say no LLDP for the one I don't want to do, right? No LLDP transmit, I'm not going to be sending messages, but I'm still receiving. No LLDP receive, I'm not receiving, but I'm still sending. However, remember, the packet tracer activity has you enter in both commands in order to make sure that you receive the points. But again, I wanted to diverge from the activity to show you sort of real world what is going to end up happening there. All right. So now it's saying disable CDP on the HQ switch 1 and HQ switch 2 switches. So here is the HQ switch 1. So let's knock this out and we'll bring this over here. And we'll pull this up and we'll get into privilege exec. And a quick note, you can say disable to go from privilege exec back to user exec. But what if I said show CDP? Yeah, I can see that information here, show CDP neighbor, right? So from user exec, I can run show CDP and show CDP neighbor commands and I can see the output. But let's get into privilege exec mode here, into global config, and we want to disable CDP on these switches. So I'm going to say no CDP run, and you can see we have 32% complete. That puts us at 37. We'll pull that up and we'll bring, whoops, we'll bring this over here. And let's get into global config and we'll say no CDP run. And so we should probably go to 41 or 42 and we go to 41%. So now we're going to enable LLDP on the headquarter switches, right? So let's go ahead and say LLDP run. And we get, what was it, 5 percentage points there. We'll come over here and we'll say LLDP run. Now, we've turned it on globally, which means on every interface that's up here, we're multicasting out that information. Now, take a look at what it's asking us to do here. It says on the HQ switch 1 and switch 2 switches, configure the links to the HQ router to only send, not receive. And again, remember, we're sending from the HQ, I'm sorry, we're receiving on the HQ router, we're not sending. So on the switches, we don't need to receive, so we're going to configure them to just send. And so how would we do that? Let's take a look at those. I think it's gig 01. So it's gig 01 and gig 01 are my switch interfaces. So let's come onto those switch interfaces, int gig 01, and we want to send, I'm sorry, we want to send on these interfaces, not receive. So I would say LLDP transmit. Again, remember, packet tracer's forcing me to put this in to get, if there were any points associated with that, and then say no LLDP receive. And we got points for that. All right, so let's come over here to this and go into int gig 01. We're going to say no LLDP receive and LLDP transmit. And again, on the switches, we did not, for the transmit command, we didn't get any points. And again, remember that we really don't need to say LLDP transmit because we've enabled it globally. And it is running on all the interfaces that are up. Again, I'm putting those commands in under the interfaces with the assumption that packet tracer may be withholding points from us like it did on the HQ router when we were working with the HQ router. So we're good there. So now it says disable LLDP completely, which means we're not transmitting or receiving on the access ports that are in use. So these two ports that come off HQ1 and HQ2, HQ switch 1 and 2 respectively. So fast Ethernet 024 and fast Ethernet 01. And so we'll go into fast Ethernet 024 and we'll say no LLDP, LLDP transmit and no LLDP receive. And again, we get the points for that as well. We'll come over to this switch here and we'll get into int fast Ethernet 01, no LLDP transmit, no LLDP receive. Now, why would we do that on this link facing hosts? It's the same reason that you would passive, and you would do it up here on the router, right? You would passive the interfaces on the router from an OSPF perspective because we don't want the OSPF hello packets being sent out on these links because maybe the PC user down here is a bad actor. Maybe they've got Wireshark installed on this PC and they're sniffing the wire, right? And they're capturing packets, and then they can see your OSPF information in your packets. Maybe you're not doing any kind of hashing, right? And so it's the same reason here. We don't want the NTP server, if it was compromised, to be receiving LLDP multicast on this link right here, right? And the same thing here with the PC, because just like I'm sitting here with Wireshark capturing all this information, and I'm getting a lot of good information here, right? The port subtype, I'm getting the port information, the system name information, we're getting the port description information, right? So I'm receiving all this information here, which you might not want a bad actor to receive, right? And there's the management address, and that's that IP address associated with the interface. So now I know the interface of the device that's sending the packets, and now I can go to work against that interface from, you know, a malicious, maybe a hacker standpoint, and you don't want that. And so that's why we want to say no LLDP transmit, no LLDP receive, because we don't want to receive any messages down here because we don't have anybody down here that's going to be capable of sending LLDP. So turn it off completely. Again, think of it, again, the analogy of passiving or making passive an interface from an OSPF perspective facing a LAN segment. We don't want that information being multicasted out or broadcasted to everybody that's out there, right? We don't want that to be happening. All right, so now we've got some CDP information that we're going to be working with here. So first, we're going to activate CDP on the branch router. And it says activated, and that tells me that it has been deactivated at some point. So let's check that. Oops, sorry about that. Let's say Control-Shift-6. So we'll go from user exec to privilege exec, and let's say show CDP. You can see CDP is not enabled. What about show LLDP? LLDP is not enabled. So let's get into global config, and to turn it on globally, I simply say I simply say CDP run. That's going to turn the branch router CDP process on. Now, we're going to connect to the switches branch switch 1, or I should say connect to branch switch 1 over SSH. It says we're not going to be able to open the CLI window, and you can see it says configurations locked. However, I noticed that it says we can't connect to branch 2 and branch 3, that we have to SSH, and that the windows would be disabled. It should do that. It should say config locked according to the information we're given down here. Connect to the switches branch switch 2 and 3 over SSH. Again, I'm going to save us. I'll show you how to do it, but I'm just going to pull the window up like this instead of what they want you to do is to figure the information out for the IP addresses, because as you can see, that information is not available for branch switch 1, branch switch 2, and branch switch 3. That's what we're going to try to determine by enabling CDP, because we can get that information from CDP. So again, I can't get into branch switch 1, so I'm going to have to connect to branch switch 1 using SSH. Well, I've just enabled CDP on the branch router. How might I see what the IP address is of branch switch 1? Well, I could say do show CDP, but is that going to give me the IP? No, that's going to show me the CDP information. Well, what about do show CDP neighbor? Well, we're getting closer, right? I see my logical local interface. I see some capability information. Again, S for switch. When we do LLDP, it would come up and say B if the switching capability was enabled. It's going to say B for bridge, meaning switch, right? It's just the sort of the old school definition like root bridge. It's really a root switch, right? But that's what LLDP is using, is B. CDP is using S. Okay, so we're getting closer. Well, let's hit the up arrow. Let's do a question mark. And you can see, come back here, do the question mark, and it says, oh, we're out of context sensitive help. So we should note detail, right? So do show CDP neighbor detail, and now I get some interesting information. I can plug this into my addressing table, or let's go ahead and get back into privilege exec. I could say SSH -L. That is an L, not a 1. Username admin. And I need that IP one more time, 192.168.1.1. 168.4.250. And off we go over to the branch switch 1. And you can see that the username was admin. I have that in my command. The password is sw1 admin pound. And we'll say sw1 admin pound. And now I'm on branch switch 1. So I can go into privilege exec. We've got another password, switch 1 ENA access. And now I'm in privilege exec. So let's say show CDP neighbor and take a look. I see the branch router, right? And we've got two interfaces, or I should say one physical interface, one logical interface, because we may be doing router on a stick here, because we might have two different VLANs over on the right-hand side of our topology. But we've got these two interfaces connected to the other switches. And so as we just saw, I don't know the IP address of branch switch 2 or branch switch 3. However, I can say show CDP neighbor detail, and let's get this information to complete our configuration, our IP addressing table. And you can see here, switch 2 is 253, switch 3 is 254. So what I could do now that I have that information, and let me make sure it didn't want me to do something here. Configure the access ports that are in use. So what it's asking us to do, and I guess let's follow through here. So we'll say SSH -L admin, and the reason that I wanted to just pull the window up is it's going to be a little easier than having to SSH all the way through. So we'll say 192.168.4.253, and we get the password, should be SW2 ADMIN #, and now we've got to enter in another password here, SW2 ENA access #. Yeah, and this is another reason I don't like SSHing across here. SW2 ENA ACCESS is typing in a whole bunch of passwords. So there we go. So now we're on branch switch 2. Let's hover over here and let's see what interface. Fast Ethernet 01. And so actually, I'm sorry, I don't want to do that. Come back to the branch router. So what we want to do here on branch switch 2, we're being asked to configure the access ports that are in use to not send CDP messages out the port. Because remember, if I say show CDP, we can see that it's enabled globally. So if CDP is enabled globally, you have to explicitly go into an interface and stop that interface from sending or receiving CDP messages. So let's get into global config. Let's go into interface fast Ethernet. Sorry about that, 01. Oops, sorry, interface fast Ethernet 01. You can also see there's a little bit of a lag there. And let me confirm that just one more time. Fast Ethernet 01. And how do and you can notice how they phrase it here. It says configure access ports that are in use to not send CDP messages. Well, I'm in the interface here. If I say no CDP ? Let's see. You can see, do I have an option to say, well, I want to receive CDP messages, just don't send CDP messages? That option's not available here, right? So with CDP, it's all or nothing. You're either sending and receiving or you're not. With LLDP, it's mutually exclusive. I can just receive or I can just send if I want to, but I can't split those functions out with CDP. Because if I say no CDP enable and do it, you can see it's not no CDP enable transmit and no CDP enable receive, or no CDP transmit, no CDP receive. Those options aren't there. Aren't there. So the phrasing here, configure the access ports that are in use to not send CDP messages out the port. Well, as soon as I say no CDP enable on the interface level, that is it. I am not sending, I am not receiving. There is no way for me to split those two functions out with CDP. With LLDP, you can, and that is a significant major difference. And so that takes me to 93%. Okay, so we took care of that. Now let's go ahead, and it wants me to do the same thing on branch switch 3. So let's do this. We'll go ahead and save our configuration as if we were a good network engineer. We come back out to branch switch 1 and take a look here at what's going on. We've got this interface that appears that it's either converging or it might be down. So maybe it was anticipating that we were going to SSH from branch switch 2 over to branch switch 3. So I'm curious, right? Let's take a look and see. And let's say, and we need our password SW3 ENA access pound. And let's say show IP interface brief. And you can see that we've got a lot of interfaces that are up and some that are down. And what interface is this? So I'll hover over it, gig01, so I can quickly say, it shows that it is up, but for some reason it's, oh, I'm sorry. I was confusing that with the symbol that it may be down, with the red arrow. I was thinking it might be down, but its spanning tree is blocking that link. I apologize. I looked at that and I was like, oh, it looks like that link may be down. So my apologies. Link is up. Spanning tree is blocking forwarding on that link. We're back out here, branch switch 1, and now let's SSH to 254. And let me, again, put the password in here, SW3 admin pound. And then get into privilege exec and say SW3 ENA access pound. And here we are, show CDP. And you can see CDP is running. It's running on every interface, show CDP neighbors. And I see branch switch 1 and branch switch 2. Remember, I don't see the branch router because CDP packets, they are not forwarded, right? So it's whatever is on this link, that's what I'm going to see if I'm running CDP. So I see switch 1 and I see switch 2. I don't see the branch router, right? I don't see the branch router because those packets are not being forwarded. Okay, or I should say the frames are not being forwarded at layer 2. So here we go. We're on branch switch 3. Let's get into global config. Let me confirm that hopefully we've got the same port here. Fast Ethernet 01, we do. So back to the branch switch. So we'll say interface Fast Ethernet 01. And remember, it's no CDP enabled. There is no transmit and receive capability or a capability to split that out with CDP. And we've got our IP addressing done. We've got everything configured. The last thing that we're going to take a look at here is let's go to the HQ router on which we enabled NTP long ago. Show NTP status. And now it is synchronized. And our stratum value is no longer 16. The stratum value is 2. And you can see that that is the NTP server information that we had put in earlier. And so that worked out nicely that by the time we made it to the end here, that is fully synchronized from an NTP perspective. All right. Well, let's go ahead and quickly summarize a lot of the major and key points that we talked about. Again, CDP is a layer 2 protocol. The CDP sending and receiving cannot be broken out, right? It's all or nothing. To enable it globally, it's CDP run. To disable it globally, it's no CDP run. The address that the multicast packets or the frames are being sent to is 0100.0 and then Charlie. Okay, those packets are not forwarded. By default on Cisco routers, CDP is going to be on. We could tweak timers and we saw how we can get different information. So show CDP neighbors, show CDP interface. We could change the timers with a CDP timer, CDP hold time. LLDP. Not proprietary like CDP. It's IEEE 802.1AB, and that's a capital A, capital B. It's disabled on Cisco platforms by default, right? Same theory, the frames are not forwarded, right? And the address that we see, the MAC address that we're seeing is 0180.c200.000e. We can easily capture those packets. By default, it's disabled. We say LLDP run to enable it globally. No LLDP run if we wanted to turn it off after having turned it on, remembering it's off by default. Transmitting and receiving, we can deal with that individually, right? I can set an interface up to only transmit and not receive, or only receive and not transmit. And the way that we were doing that was the LLDP transmit or no LLDP transmit, or LLDP receive or no LLDP receive. And the commands are similar. Show CDP neighbors, show LLDP neighbors. Show CDP neighbor detail, show LLDP neighbor detail. Again, a lot of things that we can do. A great tool to help you find your way through the environment. Now, a final word, if you are working at a 3-letter agency or in the government, there's a very good chance that you're going to be asked to turn this off from a security perspective, because if your router or switch or device that's running CDP was to be compromised, or LLDP was to be compromised, you could get quite a bit of information, as we saw. All kinds of IP address information, iOS version information, platform information. Lots of information that somebody who's a bad actor can leverage against your environment to map it out and then make their way through it and wreak havoc. All right, well, that is going to do it for this techtorial on Packet Tracer Activity 10.8.1 on CDP, LLDP, and NTP. Thanks so much for watching, and I hope to see you in the next video.